Bismillah ar-Rahman ar-Rahim. Hello students and good afternoon. I hope you are all well and you are ready to continue our beautiful discussion on distributed systems, principles and paradigms. Is my voice clear for you? Did we talk about different forms of transparency in distributed system last session? Yes or no? Did we talk in detail about different forms of transparency in distributed systems last session? No? We didn't talk about this slide? Are you sure? So where were we? How about goals of distributed systems and distributed systems compared to parallel computation? You mean this is our last slide? We talked about it. We talked about it. Transparency in distributed systems with row access, location, and migration. Yes. So we were here, I think, yeah. Okay, and high-speed computer. Okay. So let me ask you some questions. Who is ready to answer my question? My first question. I will select. Let me. One male and one female. So we begin with females. Mrs. Zahra Hussein Ali. Mrs. Zahra Hussein Ali Az-Zaidi. Can you hear me? Are you there? Mrs. Zahra Hussein Ali Az-Zaidi. I'm talking to you. Don't worry, my questions are very simple. If you hear me, please say something. I'm waiting for you, Mrs. Zahra. Zahra Hussein Ali Az-Zaidi. I'm waiting for you. I want to ask you some questions, some simple questions about our discussion in previous session. Okay, so I am to start with Mrs. Zahra Hussein Ali Az-Zaidi. If you hear me, please say something. Low speed computer. Oh, okay. It's not my fault. It's about the servers of the university. Okay, so would you please tell your friend Zahra Hussein Ali Zaidi to answer me? Mrs. Zainab, Mrs. Mariam, Mrs. Marve, please tell your friend Zahra Hussein Ali Zaidi to answer me. I want to ask her a question, a simple question. But he do not answer. I don't know why. Mrs. Zahra Hussein Ali Zaidi, where are you? Okay, Mrs. Marvin Nofe, can you hear me? Mrs. Marvin Nofe, I'm talking to you. Can you hear me? Very good. So, I want to ask you a simple question about our discussion in last session, okay? We talked about different forms of transparency in a distributed system. If you remember, the first form of transparency was access transparency. So, can you give me a simple example about access transparency in a distributed system? If you raise your hand, I can enable your microphone so you can answer me. Mrs. Marvin Ofe, if you raise your hand, I can easily find you and I will enable your microphone so you can answer me. I enabled your microphone. If you can, please talk. Please talk. I'm waiting to hear you. Oh, so bad. Please be prepare your microphones before you attend the class because sometimes we need to talk together. Mrs. Mariam Sattar, can you talk? Do you have microphone? Mrs. Mariam Sattar. Very good. So I am enabling your microphone. So give me an example of access transparency in distributed system. Please, firstly, define what is access transparency in a distributed system and then give me a good example. Where are you? I'm waiting for you. What is access transparency in a distributed system, and give me a good example of it. Can you hear me? I asked you a question. Why don't you answer me? I'm talking to you. I asked you a question. It's a simple question about transparency in distributed systems, okay? I asked you what is access transparency in a distributed system, and also I wanted you to give me a good example about it. So what should I do? Mrs. Mariam Sattar, are you there? Can you answer me? Can you answer my question? Yes, yes, please.
Yes. Access Google hide the difference in the data. Representation and how resource and the access. Example Google or
As you can see here is written, access transparency is hiding differences in data representation and how a resource is accessed. A resource is accessed. For example, about how files are stored in servers in distributed system. We don't know how the files can be named. I'm talking about file naming in different operating systems. It's different, okay? So we don't be aware about it. It is access transparency. Okay, thank you. Now
thank you.
we can go to ask the second questions from mails. Who is ready? From mails. Mm. Oh, all of you are females in this class? Okay, it's not a mixed class, so. Storage files such as access transparency. No, access transparency is not about flash memory or something else. Access transparency is exactly about data representation, differences between data representations in different systems. For example, if you use a computer with Apple Macintosh operating systems, file naming and file formats may be different from me because I am using with Microsoft Windows. So we don't be aware of it when we are communicating and transferring files between two computers. It is access transparency. And what is difference between replication and relocation transparency? What's the difference? What is the difference between replication transparency and relocation transparency? Who can answer? Yes, Mrs. Mariam, if you can say.
Yes, دكتور.
I'm hearing, yeah.
الأكسس هو had a difference in the data representation. Or location هو had where resources is located.
And what is the difference between relocation and migration?
بل
What's the difference between migration and relocation?
location and the access, or relocation or migration.
Migration transparency hides a resource that may move to another location. For example, Google may change the location of its servers, and we don't be aware of it. Okay, it is migration transparency. But relocation, it means when we are using some resources, the location of the resource may be changed. So it is relocation transparency. I gave you a good example last session about using and working with online banking system. When you are using online banking in a car, the car is moving, okay, and you are using your online banking services. You are transferring money between your accounts. You are connected to data mobile networks, data mobile internet, okay. So when the car leaves a zone and enters another zone, I mean changing zones between in a city, and you don't lose your connection, it is relocation transparency. Was it clear? You want to give you more examples or a detailed explanation? Yes, replication makes several copies of a resource. When we are using, for example, again, Google system, we want to search something on Google, okay, and Google certainly do not use a single server. Google uses many servers located in different locations in the world. They are copied of each. So when we copy a resource and when we replicate it in different locations, we are using replication. And replication transparency means that you are not aware of it. You don't know how many copies of data are in different locations. We don't know about it. It is replication transparency. Please keep in mind, transparency means we don't know about it. We don't know about it. We don't have any information about it. It is hidden. It is hidden. That is why we say it is transparency. Okay. And let me continue. The next slide is about degree of transparency. How much transparency is good? How much transparency is good? Degree of transparency. Did you see my message on Darsa? I left a message on Darsa website about watching some recorded sessions in Persian and translating in Arabic, which was done by Mr. Aqil Ibrahim. Was it work for you? Could you see the link, and was the link correct? I mean, could you access to the recorded classes? Good. So, degree of transparency. Aiming at full distribution transparency may be too much. What does it mean? Think about this sentence. What does it mean, degree of transparency? What does it mean, degree of transparency? Yes, درجه شفافیت. Exactly. Exactly. Firstly, we must ask ourselves this question. Is a full transparent distributed system really good? I repeat the question. Is a fully transparent distributed system is really good? Maybe yes and maybe no. It depends on the application we are using. It depends on the application. Let me give you a simple example. Suppose, assume that you want to read a newspaper, for example, New York Times newspaper, exactly at 7 o'clock at morning in your email box. You want a distributed system, for example, or application exactly sends the newspaper to your mailbox at 7 o'clock in your local time, in Iraq time, in your local time. You know, its system may be located in the US. You want to read New York Times newspaper, okay? So if you want to receive the newspaper in your email, in your mailbox, exactly at 7 o'clock, at 7 morning, so it means that the system must know your location. Your location is not hidden in this case. Okay. So in this case, it's good to not to hide your location. It was about location transparency. Similarly, consider you want to print some documents. You want to use a shared printer, okay? So you must know the location of the printer. If you don't know the location, so your printed document may be produced in another continent, in another country. It is necessary to know the location of the printer. Do you agree? Was it clear? Very good. So, in some situation, a full transparent distributed system may not be a good idea. And therefore, there is a trade-off. There is a trade-off between degree of transparency and performance. Degree of transparency and performance. If you try to make a distributed system fully transparent, it means that you may lose your performance. It means that you may lose the performance. So it depends on many things to decide how much transparency is good in your system. How much transparency is good in your system. Another good example is about some services in Google. I'm sure that you have seen some messages from Google that Google wants to know your location, permit or not, allow or deny. Have you had this notification in your mobile phone or in your laptop when using Google? Sometimes when you are using Google, you will receive a notification that says Google wants to know your location, allow, deny, and you can choose. If you select allow, then Google will know your location, and it's not a location transparency. Why? Because Google wants to provide some information related to you, exactly related to you. For example, if Google knows that you live in Iraq, so it provides some news and information related to Iraq for you, because probably you may be interested in reading some information and news about your country. So I again repeat that sometimes in some situations it's a good idea to decrease the transparency, to decrease the degree of transparency. Why? Because of performance, increasing performance. Full transparency will cost performance, exposing distribution of the system. Keeping web caches exactly up to date with the master, it decreases performance. Why? Why? Keeping web caches exactly up to date with the master will decrease performance. Why? Firstly, think about web cache. What is it? Web caches. For example, when you open a web page for the first time, it takes a long time to load because there are many pictures, images, text, documents, graphic templates, and so on. Okay, but some of this information are stored in your hard disk. It is called cache, web cache. The next time when you open this website, it is immediately uploaded. Why? Because there are many images that many images that there are on your hard disk, stored on your hard disk. There is no need to download them from the master. It is web caching. But if we try to update caches in very short intervals, it decreases performance. Why? Because we need to communicate with the master. For example, in a normal form, web caches are being updated every 1 or 2 days. Every 1 or 2 days, unless you press F5 button. F5 button. If you press F5 button, it is being refreshed, and all images and all documents will be downloaded again. I mean, you are updating your web cache. But if you do not press it, after 1 or 2 days, it will be updated automatically. If you try to automatically update web caches every, for example, 10 seconds, every 10 seconds, so refreshing the web page every 10 seconds costs performance, because you need bandwidth, you need to communicate and download again new data, new pictures. Clear? So in this case, full transparency is not a good idea. Got it? If you need more explanation, please tell me. Okay. I repeat. Firstly, you must know the meaning of web cache. Web cache is about caching, about storing some huge data and information, pictures, and other documents in your hard disk when you are using a website. For example, if you open Darsa website for the first time, all the information needs to be downloaded to your computer. All pictures, all text, all templates, graphics, All things must be downloaded into your computer. It takes a long time, for example, 20 seconds. Tomorrow, again, if you want to open that website, it is immediately being uploaded. Why? Because on your hard disk there are many information and pictures, so it is not necessary to download them again. It is web caching. Okay. In transparency, we said that every copy of the data must be updated. In a full transparent system, these updates must be being done immediately. But if you want to immediately update your web cache with the master, with the server, it needs bandwidth and cost performance. So it is not necessary. You don't need to be aware of this information every 10 seconds. Normally, web caches are updated every day or every 2 days, once every 2 days. It is enough. So it's not full transparency. It is a low degree of transparency. Was it clear now? Very good. The same example is about writing on disk, on hardware, hard disk, I mean. For example, when you are typing something in Word document, Microsoft Word, you are typing an article, okay? Automatically, for example, the application is stored your document on disk to prevent losing it. For example, every 1 minute. Every 1 minute, your document is stored on disk by Microsoft Word. But your document may be changed immediately. You type new thing, you type new sentences. It is not updated with the file that are stored in disk. If you try to keep update the file you are typing in RAM, in your memory, in RAM, with the file which is stored on hard disk, if you try to keep these two exactly updated, so every 1 second it must be updated. It means every 1 second you must save. Every 1 second you must save it. Control S, Control S, Control S. It is cost performance because it needs to communicate and to save a new data in every second. It needs to access hard disk. It needs to use bus to transfer information from RAM to hard disk. It needs some resources. It needs to occupy some resources in your operating system every second. So it costs performance. And it's not a good idea. If you save your document every 2 minutes or every 5 minutes, it's good. It's a low degree of transparency, but it's a good idea, really. So full transparency is not always a good idea. I wanted to say this important sentence. Full transparency is not always a good idea. Another thing is about this concept that completely hiding failures of networks and nodes is impossible in real world. It is sometimes in some situations it is impossible to completely hide failures. For example, I remember that I said in a WAN wide area network, I mean, in a WAN, it is very difficult to distinguish between a failure and a low speed network. It's very, very difficult. Why it's difficult? For example, you want to open a website and you know that the traffic on this website is too much. There is too much traffic. Many people are going to access the website, and you are also want to access the website. You are waiting. You are waiting. You are waiting to receive a response, but you do not receive any response. So, if the website is down, I mean the server failed, or it's because of low speed of network. How you can distinguish between these two? You don't know. It's difficult. It's difficult to distinguish between server failures and low speed network. So in this situation, it's difficult to make a full transparency, a full failure transparency. A full failure transparency is really impossible in such networks. In some situations, again, it is impossible to hide location transparency. For example, suppose that you are in Iraq and you want to attend a video conference that is held in US, okay, the other side of the earth, in the US. The location is it's too far. So if you want to fully transparent this distributed system, it is impossible, because it is impossible to hide the delay of sending a message from Iraq to the US. It needs some time. It needs some time to travel a message from Iraq to the US. So it is impossible to fully hide this distance. I said to you, it depends on many things. Sometimes it is impossible. Sometimes it is impossible to fully transparent. Sometimes it depends on the application. Sometimes we don't want to fully transparent. Such as the example of printing. You must know the location of printer. So in this situation, it is not a good idea to fully transparent the location. In this case, we don't have location transparency, because you are going to print your document and you must know the location of the printer in this system. Sometimes it is because of performance. We need more performance. Performance is more important for us in compared to transparency. So in such situation, we decrease the degree of transparency. Which one of transparency be a good degree? Again, I repeat, it depends. It depends on the application we are using. Sometimes we need a full degree of transparency. Sometimes we want to decrease the degree of transparency. It depends. What does it mean in this slide? Look at this slide. You can never be sure that a server actually performed an operation before a crash. What does it mean? You can never be sure that a server actually performed an operation before a crash. A student left me a message, Doctor, please send the book before the lecture to read the topic and record the lectures and send them to us on the Darsa website. Thank you. Firstly, you can access the recorded classes in your Darsa. Okay, so if you go to previously recorded sessions, you can access them. But I cannot upload the PDF until I finish the lecture 1 because I am creating it. There is no completed lecture. So once I finish this lecture, I will immediately upload it on Darsa website. Not exactly, Mrs. Rasha. Please pay attention. Sometimes you are going to transfer some amount of money from one of your accounts to another account. Okay. So when you click on perform, okay, you must wait to receive the message if it was successful or not. You are waiting. The operation is done on server, okay, but if you don't receive anything and the server crashes, what will happen? Your transaction is completed or not? You cannot be sure. Maybe just after completing your transaction, server fails. Maybe. In this case, you do not receive any message again, okay? And on the other hand, before completing your transaction, may server fails. So in this case, you cannot receive any response again. So you can never be sure. In such situations, you must wait 1 or 2 days or 3 days and then after 2 or 3 days you can be sure that what happened exactly. Was it clear? Do you want I repeat? Yes, what? Yes, clear or no? Okay. Suppose you are going to buy something, okay? You are going to buy apple. You go to a store and you want to buy apple, okay? In payment time, you use your credit card, okay? You use your credit card. You enter how much is the cost. You enter your password, and then okay. So you are waiting. You are waiting in this time. The transaction is not successful. The transaction is not successful. The money is you paid the money, but the transaction is not successful. So what happened? You can never be sure that a server performed your operation before crash or not. There are two situations. In the first situation, your operation was successful, and once just after completing your operation in the server crashed. In this case, server could not send a message to the pause you are using it. So you don't receive a notification that the transaction was successful. You don't receive it. But your transaction was successful. In the second situation, when server is working on your transaction, crash. Your transaction is not complete and server is crashed. So in this case, also you do not receive any response. In these two situations, you don't receive any notification, but you can't be sure if your transaction was successful or not. It's difficult to distinguish between these two. So you must wait 2 or 3 days. You must wait 2 or 3 days. If money go back to your account, it means the transaction was not successful. If money doesn't go back to your account, it means that the transaction was successful. Well, so in this case, full transparency is not possible. Failure transparency, I'm talking about it. Fully failure transparency is not possible in this case. And about openness of distributed systems, we talked about it. What does it mean, openness, or what is an open distributed system? What does it mean?
سلام دكتور. In the means of openness, you can add a hardware devices and software devices to expand the operating system.
Exactly. Thank you. Thank you. It's about, you're welcome. It's about extension of distributed system. How we can make a distributed system open? We must use some standard protocols for syntax, and description of instructions we use. For example, there are standard protocols for file transferring on internet, okay, called FTP, file transfer protocol. Or there are some standard protocols for failure transparency. If we use such standard protocols for our services, it is possible to extend our system easily. It is called open distributed system. So interfaces are very important for open distributed systems. Have you heard about IDL? IDL, Interface Definition Language, IDL. It's about interfaces. To have openness in our distributed system, it is very good idea to use IDLs. Can you hear me? Mrs. Marwan, Mrs. Zainab said no sound. Okay, so to have open distributed systems, systems should conform to well-defined interfaces. I said interfaces are the prominent key for openness in distributed systems. Systems should support portability of applications. If an application is portable, it is easy to execute the application on another machine. So it helps us to make our distributed systems open. Systems should easily interoperate. Interoperate means operation between each other. And I didn't ask you a question. I said that if we want to make a distributed system open, it is a very good idea to use IDL. I asked you what is IDL? Interface Definition Language. It's for creating IDLs for interfaces. Interfaces are the most prominent key in openness of distributed systems. Interface definitions can be found in ideals, okay, and they declare every function with parameters, the number of parameters, and return values, and exceptions. If you are a programmer, so you are familiar with these concepts. Okay. Achieving openness. At least make the distributed system independent from heterogeneity of the underlying environment, hardware, platforms, and languages. What does it mean, hardware and platforms in openness? See openness in point view of hardware. Yes, in hardware, I said that openness is about extension of our system. Okay, uh, one dimension is about hardware. I mean, you can easily add some new hardwares, new machines, new hardware to your system. New printers, for example. It will be possible for you to easily add new printer to your distributed systems. It's about hardware. Platforms. Platforms mean different platforms such as mobile phones, computer laptops, and different operating systems with different languages. Languages, programming languages. So policies versus mechanisms. Implementing openness. How to implement openness requires support for different policies. Which are those policies? The first one is, what level of consistency do we require for client cache data? Consistency being updated, different copies of data. For example, client cache data and the main data stored on server. How much consistency do we require? Which operation do we allow downloaded code to perform? Which operation do we allow downloaded code to perform? And which quality of service requirements do we adjust in the face of varying bandwidth? What level of secrecy do we require for communication? These are policies. These are policies that we must be aware to implement openness. But ideally, a distributed system provides only some mechanisms, not policies. Which are mechanisms? Allow dynamic setting of caching policies, support different levels of trust for mobile code. What does it mean, mobile code? What does it mean, mobile code? Mobile code is being executed on client side, not on the server. Client side. For example, when you want to fill a form for online banking, okay, you want to create new account, and so you must fill out a new form, a form of your information, your name, your family, the name of your father, your national number, and your birthday, and so on. Okay, you need to fill out this form. And for example, if you enter a wrong email address, you know the email address has a type, has a form, has a specific form. The first part is some characters, then @ character, then some other characters, then dot, and then some other characters. For example, you enter 1 @ 1.1. It's not email address. You submit the form. If this form is being processed on the server side, and then the server sends you a message that it's not a correct email, please enter a correct email, it is called the server code, okay? But mobile code is something that runs on your computer. When you open the website and you are going to fill out the form, when you click on send data, immediately before sending the data to the server, you will receive a notification that this is not a correct email. It is a mobile code because it is executed on your computer. Like JavaScript. JavaScript is a mobile code. Clear? So, support different levels of trust for mobile code. It's a mechanism for implementing openness. Provide adjustable quality of service parameters per data stream and offer different encryption algorithms. Offer different encryption algorithms for what? To increase the security. We talked about it, that using many shared resources and many machines connected together in a network for having a distributed systems will raise an issue. What is the issue? It's about security. So we can use different algorithms to encrypt data. Encrypt means RAMs. Encrypt data. For example, your password must not be saved, must not be stored as a text in the database in server. It is stored as an encrypted data. and there are many different algorithms to encrypt your data. So it will be difficult for استراق السمع. استراق السمع means you know what is استراق السمع? استراق السمع in English we say eavesdropping. I don't know. In Farsi we say استراق السمع. It means شنود بی اجازه. I don't know. But in Arabic I don't know what's the word in Arabic. الأمنية. Yes, Mrs. Mariam. Attentive. Yeah, Mrs. Mariam. I think it is the word in Arabic. So, in a network, someone may steal information when you are sending information and data from your computer to the server, for example, bank server. Between you and server, someone called hackers may listen to the data you are sending and steal them. So you must encrypt your data. How you can encrypt your data? There are many encryption algorithms that you can use them. Okay. And about scalability. Okay, it's enough for today. We can talk about it next session. So here it's enough. I again repeat that I left a message on Darsa website to see recorded previous sessions in 13 class. In number 13 class, Mr. Aqil Ibrahim translates my speak to Arabic. So if you have some difficulty with English, you can use those recorded classes. Let me show you I'm going to show you I share my screen. You can see my screen. Okay. Can you see my screen now? Very good. Here. On the Arso website, you can see here Class online. Okay, if you click on this link, you can enter the class with this ورود به class. Okay, and لیست ضبط ها means the previous recorded classes, your classes. Okay, here نمایش آنلاین، لینک آفلاین. Okay, and I back to this page again, and here I put you a message. If you want to see the previous translated sessions, you can see